We want to consider the topic of geometric series again, but in a slightly different way. So I invite you to think about the expression 1 over 1 minus x. And I'm going to ask, if you just think for a second, you can even pause the recording and ask, what, what series is this equal to? Well, the answer is that if I had instead asked what 1 over 1 minus r is equal to, you very readily would have come up with the geometric series. In other words, this is, we know that n equals 0, sum from n equals 0 to infinity of r to the n, that's just a geometric series with the common ratio r, and its sum is 1 over 1 minus r. Well, that really shouldn't change just because I've changed the name of the symbol from r to x. So it is correct to say that 1 over 1 minus x is equal to the sum from n equals 0 to infinity of x to the n. All I've done here is I've just changed the name of the symbol in this expression. And by the way, when is this expression equal to 1 over 1 minus? When is this series equal to 1 over 1 minus r? The answer is that we know that's true for the situation where absolute r is less than 1. So this is true as long as absolute x is less than 1. So it kind of seems reasonable to say that this is a power series that converges to this value as long as as long as we are within the radius of convergence of 1. Clearly, this is a power series whose center is 0. So it's correct to say that this power series, if I draw it on a number line, converges in exactly that interval. So the point that we're getting at, and by the way, I know I've labeled this geometric series redux, where I'm just using the term redux to mean revisited. Some people have come to me and said, I was looking up some more information on the internet and I wanted to find out about this mathematical process of redux. Please don't do that. It's not a mathematical process. It's just my way of saying that we're revisiting the topic. The reason that we're revisiting the topic is, suppose that I had come up with this. Suppose that I had told you, this is important enough, I want to put it in purple. I had told you that f of x is equal to 1 over 1 minus x. You'd recognize this as sort of a function, right? In other words, this is in fact the function that just looks like this, right? It is a function. And what I could ask you is, what power series is equal to this function? And it would be completely reasonable to say that at least within the interval -1 to +1, at least within this interval, so for this part of the function, it would be totally reasonable to say that that function is equal to the sum from n equals 0 to infinity of x to the n for values of x whose absolute value is less than 1. That's where we're going with this, is that functions can be represented by a power series. In fact, this power series we've already shown through this argument above is exactly equal to the same thing as this function, as long as x meets this constraint that x has to be between -1 and +1. Okay, so if that's true, what power series corresponds to this function? Well, the answer to that lies in being able to rewrite this function in this way. Everyone agree that 1 over 1 minus -x is the same thing as 1 over 1 plus x? Well, once I've written the series in this form, I can simply treat this like it's the r in that formula that we learned a couple of sections ago, and I can say that therefore this is equal to sum from n equals 0 to infinity of this term, -x to the n, which normally I would write this way. I'd normally pull out the negative and give it its own power, so that's -1 to the n, x to the n. So now this looks more like a power series, where here, this part here, the -1 to the n, that's that an term that we covered in the introductory definition of a power series. So this is a power series that, as long as we're within absolute value of x is less than 1, that is, this is a power series that is equal to this function. And in fact, they would be the same. If I were to plug in, let's say, if I were to plug in, let's say, the number 1/2, and I wanted to know what that series sums out, what it comes out to, I would simply use this expression. I'd write 1 over 1 plus 1/2. That'd give me 1 over 3/2 or 2/3, and that would be the sum of this series. We already knew that in the context of geometric series. We're just sort of extending it to the case where x is a variable.